Hi everybody, welcome to this next video. So in this one we're going to be looking at Pythagoras trigonometry, and then I'm going to go on to the more complex trigonometry as well, which would be just for hire. So worth watch, there'll be quite a lot of stuff in here. I'll put the timestamps below, so if you do want to skip to certain sections, then there's certain parts you can look at. Worth noting that trigonometry could come up in a paper 1 because of your exact values of trig. So if you're not 100% sure on exact values of trig and how to use them, watch the video I've done on that as well. Okay, so let's jump straight in. Look at this first one. So the thing that you need to identify is that in a right angle triangle, so we've got here, this is clearly a right angle triangle, you are looking at whether or not you use Pythagoras or whether or not you use trigonometry, and think about it's all to do with angles. Okay, so if there's an angle involved, and what I mean by an angle is not this one, I mean the other ones here and here. If there is angles involved, you're more than likely going to be using trigonometry. And if there's no angles involved, so I haven't got any angle here, haven't got any angle here, it's not asking me to find any angles, then I'm going to be using Pythagoras. So Pythagoras is all about the sides, trigonometry is all about angles. Now hopefully what you know, or if you don't know it, here's the formula. A squared plus B squared equals C squared. Okay, now C is always the longest side. So if you're not sure about that, it will always be the longest side of a right angle triangle, and that side will always be diagonally opposite to the right angle. That's called your hypotenuse. Okay, so HYPOTENUSE, hypotenuse. Okay, and that is your longest side. So technically, in this example here, that side is called C. Okay, then A and B are the other two sides. A and B don't matter. There's A and there's B. Okay, now the reason this works is because if you were to draw a square off the side of this triangle there, and a square off the side of this triangle there, and if you were to work out both those areas and add them together, you would end up with the same area as I would get off that side there if I was to work that out. That's why Pythagoras works, but if you can remember the formula, that's going to be the most important thing. Now a quick way you can remember it is square, so square the side, square the other side, add the two sides together, and then square root. Okay, and that basically tells you your process. Square, square, add square root. Let's look at what that means. So I'm saying a squared, which is 11 squared, plus b squared, which is 8 squared. So you're doing, so I've got the calculator up here so you can see, 11 squared, we know it's 121, plus 8 squared, which we know is 64. Altogether that gives me 185. So what I've done there, for those of you that aren't happy with the formula, and you want to kind of think about it in a repetitive way that you can remember, square, so square, square, add them together, and then this last step of square root, all you need to do is take the square root of that 185. So in this case, I press my square root button, 185, close my bracket, press equals 13.6 centimeters. Now, the way you can check that you're right is that this will always be the longest side, okay? So the hypotenuse, the slope, so imagine this if this was a ramp, the slope of the ramp here will be the longest side, and that's what I've got there, 13.6 is my longest side because the other two sides are 11 and 8. If you ended up getting a number there that was less than 11 or 8, then you know you've made a mistake. So the slope of a ramp, the hypotenuse, will always be the longest side. Okay, so just make sure you're aware of that and you remember that. So let's look at this next example here. So it's rotated slightly differently. Now what we're looking at is that my right angle's here. So this side here is my slope of my ramp. So that's actually C. So I've been given a longer side now. Okay, so that is my longer side. I still would label this A and B, but it doesn't actually matter which way around you label it. I'm going to call that A and that B. It doesn't really matter. Now your formula here is slightly different. It's because we're now trying to find B or A, depending on which bit you are being asked to find, I'm going to say that B squared is equal to C squared minus a squared. Okay. Now the way you can remember this is because that is no longer a longer side. I'm not being asked to find the slope. I'm not being asked to find the longest side of the triangle. So this is now technically one of the shorter sides. Okay. And the way you can remember this is that if you are asked to find a shorter side, you subtract. And what I mean by that is we still follow our process we had up here, our square, square, add, square root. But instead of saying add, we're going to go square, square, subtract, square root. So if you're not happy using the formula I've given you here, b squared is equal to c squared minus a squared. Okay, if you want to think about it like this, square the side, subtract. The reason we're subtracting is because we're now finding a shorter side, and then square root. So let's look at this, what this would look like in this question. So we're saying 17 squared, make sure you always take the longest side there, minus 9 squared, so 17 squared minus 9 squared gives me 208. So I've squared, I've subtracted, and then my last step, square root 208. So square root 208, and I get an answer of 14.4 centimeters. Now that looks like it makes sense to me because it's not longer than that side, and it would be in proportion to these two sides here. So that is how you do your Pythagoras. So first one, if you're finding the actual slope, the slanted height, or the hypotenuse, you square, add them together, then square root, or a squared plus b squared equals c squared. Remembering c is your longest side. And if you are finding one of the shorter sides here, so you're no longer finding the slope, one of the other two sides, you're doing b squared or a squared, doesn't matter, is equal to c squared minus the other side, or you can remember it as square, subtract, square root. Okay, so remember, Pythagoras, all to do with sides, nothing to do with angles. So let's now move on to trigonometry and what happens and how we can identify trigonometry. So notice the difference here, right? This has now got an angle involved in it. Previous examples here, no angle there, no angle there, no angle there, no angle there. This is just about an angle and a side, and it's actually saying to me, find AC. So this side here I'm going to call X because that's what I'm being asked to find. So this is, I'm finding a side, but it's got an angle in it. So because it's got an angle, I know I'm using trigonometry. Here's how I like to teach this. Here's how I like to remember this. So you need to remember your triangles. So sin, opposite hypotenuse, cos, adjacent hypotenuse, tan, opposite and adjacent. There's many different ways you can remember this layout. Okay, whatever way you remember Sakatoa, you just need to find your method of remembering those triangles. Now, each one of these triangles that we have here forms a formula triangle. So what I'm basically going to do here, set it up as a formula triangle, and that would mean that divide would be here, times goes there, divide would be here, times goes there, divide would be here, times go there. Now let me explain what I mean by that. If I was being asked to find the opposite at the top, I cover it up, and then therefore I multiply these bottom two values. If I was being asked to find the hypotenuse here, I then do this divided by this. So we use those formula triangles to help us. So I'll show you what this looks like in context. Let's start going through what we do step by step. So the first thing you have to do is you have to label the triangle opposite, adjacent, and hypotenuse. Now, if we look back to the previous example where we were doing Pythagoras, the hypotenuse is the longest side and it's the slope. So this side here becomes h. The opposite is the angle, the side that is opposite the angle you've been given. Not the right angle, the angle you've been given. So this x is called the opposite. And then the adjacent is the one that is next to the angle. If you leave that one till last, you know it'll be the only one left over. So your step one is to label the sides. So I've done that. What I now need to do is I now need to pick whether or not I'm going to use sin, cos, or tan. I've got to find the one that is the most, I've got to find the ratio that works. Can't just pick a random one, I've got to find the one that works. Now if I look at this question here, you've got to think to yourself about which one of these three sides is not important. Now, I've been given the adjacent, so that's important. I'm being asked to find the opposite, so that's important. Therefore, this hypotenuse is not important, okay? So, not important, which means any one of these formula triangles up here that has an h in it, I can't use. So I can't use sin because there's an h there. I can't use cos because there's an h there, which means I have to therefore be using tan. So what you do is you take that formula triangle and you write it out. Tan goes in the bottom left, opposite goes at the top, adjacent goes in the bottom right, and from here what you're working out is the missing values. So tan 32 goes in this bottom left. So tan 32 goes in the bottom left. At the top, opposite is x, because I can see that's that one there. And in the bottom right is the adjacent, which is 11.4. So I've filled in my formula triangle with the piece of information I've got. And now, because I've got the information filled in, I can figure out what to use here to solve the problem. You have to ask yourself, which one of these three things am I being asked to find? I'm being asked to find x. So if I cover up x, you have to do this multiplied by the other value at the bottom, because there's a times sign there. So x is equal to tan 32 times 11.4. And if I do that on my calculator, so I type in tan 32 times by 11.4, and by doing that I get an answer of 7.12. So therefore my answer is 7.12 centimeters. Okay, so that would be your answer for this question here. So let me quickly recap the steps there. First thing to do, label it opposite, diagonally opposite to the angle, adjacent, the one next to it, and hypotenuse is the longest side. So label it opposite, adjacent, hypotenuse. Then you pick which one of those three is not important. The hypotenuse is not important, so therefore I don't use an h, so I can't use that one, can't use that one. And then tan is what I'm looking for, so I use this formula triangle. Tan of the angle in the bottom left, opposite goes at the top, the opposite in this case is x, and the adjacent goes in the bottom right, which is 11.4. And then whichever one of these three you're finding, you cover up. So I'm finding x, so I cover that up, and therefore I multiply them. If it turned out it was the adjacent in the bottom right I was looking for, I would do opposite divided by tan of the angle. Let's look at this bottom example here, and you'll notice it's different because actually it's now asking you to find an angle. Anytime you're being asked to find an angle, you must use the inverse function. And the inverse function is sin minus 1, cos minus 1, or tan minus 1. But the rest of the process is exactly the same. So let's start this question off, first of all, by labelling again. My angle's there, which means this side is the opposite. This side is the hypotenuse because it's the longest side, and this is the adjacent. I go back again and I write out my SOHCAHTOA so I can figure out which one not to use. In this case, I've been given the opposite, I've been given the hypotenuse, so adjacent is not important. So I cross out cos because it's got an A in it, I cross out tan because it's got an A in it, therefore I know I'm using sin. I write out sin and then opposite and hypotenuse down there. And then I substitute in what I know. I know the opposite is 7.3, So 7.3 goes at the top. I don't know the angle, that's what I'm trying to find. So this time, in the bottom left, you put sin minus 1 because you're finding the angle. And in the bottom right is the hypotenuse of 11.5. And this now is what I'm trying to find. So I cover this up. And because I'm covering that up, it means you are dividing. So when you are finding the inverse function, so when you're finding an angle, you use the inverse function. So you'll press, a lot of the time on a calculator, you'll have to press shift and then press sin, cos or tan. Or in this case, I've got a sin minus 1 already that's come up. You can see there, sin minus 1. And then it's 7.3 divided by 11.5. So making sure that you are dividing. So 7.3 divided by 11.5. Close my brackets. And I get an answer of 39.4 degrees. Now it may say to give your answer correct to the nearest degree, or it might ask you to round it to a suitable degree of accuracy. But key thing to remember, the process is exactly the same as the one above, except for the fact that in the bottom left, you substitute in sin minus 1, cos minus 1, or tan minus 1. Okay, so that is your basic Pythagoras and trigonometry, when to use it. If you were to look at these two questions now, you can pause the video and have a look actually at how you would then answer these kind of questions where it's not obvious you've got to use Pythagoras, it's not obvious you've got to use a bit of trigonometry, but see if you can figure out how to answer these questions. And after you've done that, unpause the video and I'll go through it with you. Okay, so looking at these, the first thing you should identify is that this side would also be 5, this side would also be 12. So altogether you're doing 12 plus 12 plus 5 plus 5, which gives you a total of 34 meters. The thing that you are currently missing is this diagonal one though. So if I put a right angle there, I can see straight away that this creates my right angle triangle, and therefore this side here is the hypotenuse. So it's the longest side, therefore I'll be doing a squared plus b squared, or square square, and then add, and then finally square root. So 144 plus 25, which is 169, and then your square root of 169 to get 13. So this length here would actually be 13 meters. Okay, so altogether, I then add that 13 on, and I end up with 47 meters is the total amount of wood that I would need to build this frame. I know that each meter of wood costs £5, so you're basically saying 47 times by 5. If you're not comfortable doing it without a calculator, 47 times by 5, 235. Or if it was in a paper 1, for example, you could just do 5 times 40, which is 200, and then 7 times 5, which is 35, and add them together. But altogether, what I'm saying is this would cost me £235. So an example of a problem solving question there where Pythagoras isn't that obvious, but in that case it is. In this next one, straight away before we even look at it, I can see that there's an angle. So the likelihood is I'm probably going to need to use trigonometry in this triangle. And in this triangle here, I actually may not need to because I've already got two sides. But let's read it and see what we've got. So it says ABC, so ABC, and BDE, so BDE, are two right angle triangles. So there's my two right angle triangles. It tells me AC is 15, B to C is 12, so the whole length here is 12. BD is 10, and then BDE is a total of 40 degrees. And when you've got angles written like that, BDE is the middle one that is the angle, so B to D to E, that's the 40 because the D is in the middle. It wants the area of the total shape. So the best thing to do here is to actually draw it as two separate shapes. So I'm going to draw out this one here, which is my A, B, C. And I've got 12 and 15 centimeters that I've been given so far. Now, that would be my right angle. I'm going to find the area of this shape first of all. Now, to find the area of a triangle, if you're not 100% sure, it's base times the height, and the height is the perpendicular height divided by 2. So the base would be this part, and the perpendicular height is not 15. That's the slanted height. That's the slope. That's your hypotenuse. So base times perpendicular height is that. Or if you flipped it around, that would be your base and this would be your perpendicular height. So you're looking at the two sides that are perpendicular to each other. So I'm going to say it's 12 times something divided by 2. Now the problem is I don't know this height here, but I can find it because this is a right angled triangle. So I would say 15 squared, and then I've got 12 squared. Now remember, think to yourself, this is a shorter side. So you're doing square, square, and then subtract. Or if you're using the formula, you're doing c squared minus a squared is equal to b squared. Or you could say c squared minus b squared equals a squared. So I'm doing 15 squared, which is 225, minus 144. So using your calculator, 225 minus 144 gives me 81. And then we're square rooting 81, which hopefully you all know, but if you're not 100% sure, is 9. So that height there is 9. That is my perpendicular height now. So I end up doing 12 times 9 divided by 2. There's a couple of ways you could do that. You could actually do 12 times 9 is 108 and then divide it by 2 to get an answer of 54 centimeters squared. Or what you could do is just half 12 to get 6 and then do 6 times 9, which is 54 as well. So what I'm saying is this first shape here has an area of 54 centimeters squared. So I'm going to keep that in the bank. That's what I know. I now need to figure out the other part, and I need to understand exactly how what the area is of that one. So let's just move that to the side. I'm going to redraw this second triangle here. So we've got this shape like this. That's my 40 degrees. Tells me that's 10 centimeters. So again, if I put my right angle there, I want to find the area of this. So it's base times height divided by 2. This bit here would be your base, okay? And this part here is your height. Or again, it doesn't matter, you could do it the other way around. But remembering that this is not your height or your base because it's the diagonal length. So I'm saying here, something times by 10 divided by 2. Problem is I've only got one side, and because I've got an angle, I know I now need to use trigonometry. So let's label this side opposite. The hypotenuse is the longest side there, that's the slope, and the adjacent is that. So we're going back to the method of trigonometry. I then write out my SOHCAHTOA, and now I need to figure out which one of these three sides is not important. Well, the hypotenuse is not important because I've got no information and I'm not needing it. So I can cross out sin, I can cross out cos because they both got an h in. So I know I've got to use tan. I've been given the angle, so it's tan 40. In my formula triangle, the opposite goes at the top, and the opposite in this case is my base, so I'm going to call it x, and the adjacent goes in the bottom right, which is 10. I'm trying to find x here, so what I need to do is tan 40 times by 10. So you're doing tan 40 times by 10, and on your calculator, if you just go tan 40 multiplied by 10, that gives you an answer of 8.39. I'm going to keep that as accurate as I can. 8.39, because that's 8.390. 99, I'm going to leave it as 8.39. So I'm saying that the base here is 8.39 centimeters. And then I can go back to using my base times height. So this will become 8.39 because that's my base, times by 10, which will give me 83.9, and divide that by 2. So 83.9 divided by 2 gives me 41.95. So this would be the area of that second shape. So I'm not done yet. Let's remove that. So it's got a bit more space. Remember the question here says find the area of the total shape. So you'll be taking the 54 and the 41.95. So you're saying 54 plus 41.95 and then you'll get a final answer of 95.95. And that would be your final answer for the area in centimetres squared, because it's area. Okay, so a couple of examples there of where Pythagoras trigonometry can be seen, and it's not massively obvious that you need to use it, but just be aware of looking for it whenever you can create a right angled triangle. So if we look now at this more complex stuff, this stuff here will be for higher, and I'm going to talk you through a couple of different formulas. As I say, this wouldn't come up in the foundation paper, this would only be on higher. So, area of a triangle that is non-right angled, the formula you're using is half AB sin C. So, very, very different to what we've just been looking at, where we've been looking at right angled triangles. Half AB sin C is how you find the area of a non-right angled triangle. Now, I like to refer to this as an angle sandwich. So what I mean by that is you can only use this formula if you have an angle and then two sides either side of it. So effectively, that's your two slices of bread. This is your angle in the middle. So you have to have an angle sandwich to use this. Okay. If you don't have an angle sandwich, you've got to try and create one. So it could be that you find missing angles and know that it has to add up to 180, but you're looking for an angle sandwich. So a half times A and B. Now A and B are your two slices of bread. So I'm just doing 17 times 19, and then times sin of whatever angle it is you've got there, which is 48. And that will give you your area. So 0.5 times 17 times 19, and then times sin 48, close your bracket, gives me a total of 120 centimetres squared, that would be. Okay, so area, half AB sin C, is a formula you need to remember. You can only use it in an angle sandwich. Either side is the pieces of bread, that's your A and B, and then the C is the angle that you're looking for. What I suggest you do in an exam is you almost cancel these out, ignore the letters in the corner, and then rewrite them to suit your needs depending on what formula you're looking at, because in the next formula, a little bit more complicated, we're now needing an angle sandwich again. So you still need an angle sandwich, but in this case, we're using a different formula because it's asking me to find the length of a side. BC is this one. If you're finding a side that is opposite an angle and you have an angle sandwich, then what you're going to use is this formula. So this is the cosine rule. Okay. Now the cosine rule you use to find the length of a side when you have an angle sandwich. So these first two examples, you must have the angle sandwich. First one's for area, second one is to find a side. So the B and the C now are the two slices of bread. So this becomes B, this becomes C. So in the previous one it was A and B, this time it's B and C. The capital A is the angle side, and because this is what you're trying to find, you label that little a. The most important thing here is that the side you're trying to find, you label little a. Then it's just a case of substituting in all the pieces of information you know. So 17 squared plus 19 squared minus 2 times 17 times 19 times cos this time, and it's cos 48. That will give you a squared. So if we type that into our calculator, we're going 17 squared plus 19 squared minus 2 times 17 times 19 times cos 48. That gives me an answer of 217.742. I'm going to round that to. And then, because that's a squared, you then have to find a by square rooting your 217.742. So do not forget to square root as your final step. So square root of 217.742 gives me an answer of 14 0.756 centimetres. So I could say that that rounds to 14.8, depending on what your answer asks you to round to. And that makes sense. If you look at the other two sides, 17, 19 and 14 would make sense. Okay, so the first couple of bits there, making sure you've got an angle sandwich, and looking at changing the letters of the triangle depending on what suits your needs. So let's now look at the third example here, which is going to be the cosine rule, but this time it's finding an angle. Okay, so cosine rule, finding an angle. Now, if you look at the original formula, a squared equals b squared plus c squared minus 2bc cos a, that initial formula, what we need to do is we need to basically rearrange it so we've got this on its own. So by doing this, what you're actually looking at doing is isolating that. So let's break this down. So we can look here at basically swapping and rearranging these sections apart to get that cos A on its own. So because this is a minus 2bc cos A, what I'm going to do is I'm going to take that over that side, and it's going to become a squared plus 2bc cos A equals b squared plus c squared. Then what I'm going to do is I'm going to take this a squared over this side, and it becomes 2bc cos A is equal to b squared plus c squared, and then minus a squared. And then I now need to again isolate this. So what I'm taking is this 2bc over this side, and because this means 2 times b times c times cos A then stays on its own, and I move that over and it becomes a divide. So it's b squared plus c squared minus a squared, all divided by 2bc. And finally, to get it in the correct format, because we are finding an angle, like we said in the previous right angle triangle stuff, when you're finding an angle, you use the inverse function. So it's cos minus 1, and it's b squared plus c squared minus a squared over 2bc. Now you've got a couple of choices here. You can either just remember that formula, or if you understand the process in how to rearrange it like I've just done there, then you can just remember the first formula that we did up here, so you can remember this one, and then rearrange it so you end up getting isolating that. So it's up to you, whichever one you find easier. So that's our formula we're using. Now we need to make sure we label the correct things. So in this question here, we're trying to find this green angle here. So because that's the angle I'm trying to find, I'm going to label that A. So the angle you're trying to find is capital A, which means this angle opposite, this side opposite has to become little a. Key thing to remember is the first angle you're trying to find is capital A, and then the side is the lowercase a. Then B and C actually don't matter, as long as your B and C, again, like we said with that angle sandwich, your B and C are either side of your angle. So I'm going to call that B, and I'm going to call that C. In the same way as we did here, that was the angle, B and C were either side of it. Okay, so from here, I then just take that information and I substitute it into my formula. So cos minus 1, b squared is 18 squared plus 13 squared minus 17.1 squared, all divided by 2 times 18 times 13. So that would be my formula that I would have. And then I go to my calculator, so type in my cos minus 1. Now you would have a fraction button that you can open up, but I'm going to just put this all, the top bit, in brackets as well. So plus 13 squared minus 17 squared. So that's the top part of my equation. And then divided by, I'm going to open my brackets up here, 2 times 18 times 13, close my brackets, and then I'm going to close the brackets again. So basically what I've done there is I've opened my brackets because of the cos minus 1. I've opened another set of brackets to do the top part of the fraction, and then opened a set of brackets to do the bottom part of the fraction, so that BIDMAS doesn't affect the equation. If I didn't put those in, then BIDMAS would impact it. On a calculator for your exams, you'd have a fraction button, so you could actually press the fraction button there. So if I press equals there, I get 64.157587, and this is in degrees. So I can call that 64.2 degrees, or if it said to the nearest degree, it would be 64 degrees. Okay, so that's how you answer a cosine rule question when you're being asked to find the angle and not the side. Okay, so we're going to start looking at this next example here where it looks a little bit different. So if we think about these previous examples, we've had this angle sandwich here, angle sandwich there. So now we don't have an angle sandwich. We don't have anything like that that we can use to identify. So when you get a question like this, you need to start thinking about matching up angles and sides. So this angle matches this side, and this side matches this angle. Okay, if I was given this angle and this side, I can think about the fact that they would match up as well. So you're constantly looking here about opposites. So when you've got an angle and an opposite side and an angle and an opposite side, that's what you need to start thinking about. So here we've got BCA. So BCA is this angle here that I'm looking to try and find. Okay. The formula we're going to be using now is going to be the sine rule, which looks like this. So it's sin A over A equals sin B over B, which is equal to sin C over C. And this is the one we use to find an angle. Later on in the next example we're going to do down here, it's actually asking us to find a side. So down here, which will be the flip of this, we're going to use the reverse formula. So this formula here we use when we're looking to find an angle and we've got opposites involved. Now, because sin A over A equals sin B over B, which equals sin C over C, we can actually basically just eradicate one of them. Okay, so we're only going to be using two. Again, if I was you, I would cancel out the angles in the corner. They're irrelevant, and we're going to rename them to help us answer this question. So the one I'm trying to find, I'm going to call A. Okay, so this one in the bottom right is now what I'm trying to find, which is A, and therefore the opposite side is little a. That's going to be capital B, and this is going to be little b. So by doing that, it means I can now begin to substitute in what I know. So sin A, which is sin x effectively, that's what I'm trying to find, over A, which is 17, is equal to sin B, and sin B in this case is sin 50, over B, which is 19. So that's my formula that I've now got. I am trying to get this on its own, and because we're finding an angle, we're going to be using the inverse function. What has to happen is this 17 is a divide by 17, it's got to go over here and become a times by 17. Now, the reason that the way that you actually then end up doing this is this then turns to sin minus 1. You open your brackets and you're going to be doing sin 50 over 19 multiplied by 17. And technically, because that is a fraction here that we're multiplying, a whole number by a fraction, you put it over 1. Okay, so you're basically multiplying the top by 17 and the bottom by 1, which means you're effectively only multiplying the top by 17. So when you type that into your calculator, you'll have sin minus 1, and then open your brackets, sin 50 times 17, all divided by 19. Now on a calculator, if you have a proper fraction bracket button, you can use that. For me, I obviously don't have that fraction, so I'm going to put the top part of it, so sin 50, I'm going to put that top part in brackets, times 17, close bracket, so that's the top part of the fraction, and then that's all divided by 19 for me, and then I'm going to close that bracket, and I end up with an answer of 43.26. Depends what it asks you to give your answer to, so if I round that to one decimal place, it'd be 43.3 degrees, or if it was the nearest degree, it'd be 43 degrees. Okay, so that's how you use the sine rule to find an angle. So now let's look at the next example where actually we're now looking at trying to find the sine, use the sine rule, and we're actually finding a side now. So again, it's all about opposites. So that matches that, and that matches that. So we're using the opposite side to opposite angle. X is what I'm trying to find, but instead of now using the sin A over A and sin B over B, we're actually going to flip that upside down, and we're going to say A over sin A is equal to B over sin B. Now the bit you're trying to find, you call A, because that's the start of my formula. Capital A goes down there, B is there, and capital B is there. Remembering that all capitals go in the corners and lowercase are your sides. So let's substitute in what we know. So X is A, sin A is going to be sin, and it's 34 here, is equal to B, which is 7.2, over sin of b, which is 52 degrees. So that is my formula. And again, going back to what we did in the last one, I'm taking this over here and I will be multiplying that. So x is equal to 7.2 over sin 52 multiplied by sin 34. And again, remember, because that is a fraction here and you're multiplying this by a fraction, you can put it over 1, which means you're effectively only multiplying the top by 7.2 and the bottom will stay as sin 52. If I work that out on my calculator again, I'm going to have to use the brackets. So I'm saying brackets 7.2 times by sin 34. So that's the top part of my fraction that I'd be doing, divided by sin 52. And then close my bracket. I end up with 5.1. So 5.1 would be my answer. 5.12 if it was to 2 decimal places. So x would be 5.1 centimeters. Okay, so that's the opposite of the sine rule for there. So that's angle, that's side. Okay, so we're now going to look at this last couple of examples here that we've got. The first one here, the area of the triangle is 19.34 centimeters squared. Find the value of x. So this is to do with area. And in this case, we're actually going to be working backwards. So because it's to do with area, the first thing you should be thinking is that this is going to be using a half AB sin C again. So because we've actually been given some information about the area, we have to work backwards with this. So let's write this formula out. 0.5 times A times B times sin C is equal to 19.34. That's what we know, because I know that the area is 19.34. So if you get an example where it gives you the area, you need to then work backwards, substitute in what you know. So what do I know in this question? Well, I know what C is. So this bit here is 58, because that's your angle that you're looking for. Remember, we're looking for this idea of an angle sandwich. So there's my angle, there's my 2 slices of bread. We know that 4.8 can be either A or B, it doesn't matter. So let's call that A, let's call that B. So this 4.8 is going to go here. So 4.8 times B times sin 58 is equal to 19.34. There is no other information that I know there. I'm now trying to find B. So the question is actually asking you to reverse all this and find this value of B. Well, because all of this is multiplied, we're basically saying 0.5 times 4.8 times sin 58 times B is equal to 19.34. So because they're being multiplied, it doesn't matter which order you put them in. So again, I'm trying to isolate this B, which means all of this can move over this side, and because it's all multiplied on that left hand side, when I move it over to the right hand side, it becomes a divide. So actually what you're doing is to find B, you're saying 19.34 divided by 0.5 times 4.8 times sin 58. And if you type that into your calculator, so again, because I don't have a fraction button on this calculator, I'm going to open a set of brackets and do 19.34 divided by, and then I'm going to put all of this in brackets as well, 0.5 times 4.8 times sin 58. And when I do that, I get an answer of 9.5 centimeters. So that would be my answer to this question. I could then check that works, because if I go back to my original formula, because this is a working backwards question, if I go 9.5 and substitute that in there, and go back to the original formula of half AB sin C, so if I say 0.5 times A, which was 4.8, times B, which I'm now saying is 9.5, times sin 58, if I type that into my calculator, so 0.5 times 4.8 times 9.5 times sin 58, close my brackets, I get an answer of 19.335, which would round to 19.34. So I've already checked my answer. I know that that one is correct and that I've got the correct answer. Okay, so if you're given an answer for the area, use your formula, substitute it into first instance, substitute in what you know, and then rearrange it. Okay, let's look at this last example here now, which would be towards the end of a paper. It'd be the last couple of questions, or the last question. And basically, we're going to be combining a lot of the things we've just been looking at there. And we're also talking about bearings. So bearings is something that comes up in the beginning of the paper, it could be, but it also comes up with trigonometry as well. So you need to get your head around bearings, and we'll talk through that in a second. So the bearing of town B from town A is 047. So what that means is, from town A, so B from A, means I'm standing at A and I'm going to B. Okay, so that's my 047. So for me to travel in this direction, I travel on a bearing of 047. The bearing of town C from town B is 143. So for me to go in this direction is 143. Town B is 23 kilometers from A, so that's my distance there. Town C is 18 kilometers from B. We need to find the bearing of town C from town A, which means, so the first thing to do here is draw a line there. And what this means is I'm trying to find this whole section here. So the question's asking me to find all of that, okay? Which means, in order to find all of that, I'm going to need that part there. So you can see what I'm doing is I'm working out what it is I need. So this is the question. I figured out what it is I need. Now I'm starting to work backwards to what I can work out. Okay, so let's have a little think about this. I've got an angle there that I need to find. So that matches up with that. This would match up with this. Okay, but I'm missing some information here because I don't know any angles. So I'm going to have to then think to myself, what can I work out? Well, a key thing to remember is in bearings, if you have two north lines like this, these are both parallel. So those two lines are both parallel, which means this angle here and this angle here need to add to 180 degrees. So the first thing you should do is 180 minus 47, okay? Because co-interior rule for angles in parallel lines, these two must add to 180 degrees. So 180 minus 47 gives me 133 degrees. So this angle here is 133 degrees, okay? So that's my first thing, which means that leads me on to the next part of my question where I could actually find this angle now. Because what I know is that this angle plus this angle plus this angle has to give me 360. So the next part of your question will be to do 360 minus 133 minus 143. So 360 minus 133 minus 143, and that gives me 84 degrees. So this here is 84 degrees. Okay? So first step to find that missing co-interior, 180 minus 47 is 133. And then because we know that angles around a point have to add up to 360 degrees, we've then found the missing angle there as well. Okay, from here, we need to think to ourselves, what can I now work out? Well, I've got here two sides and an angle. So this is now made what we spoke about previously as an angle sandwich. So because I've got an angle sandwich, I can now use that information to find the length of this blue line. Okay? So using the cosine rule, a squared equals b squared plus c squared minus 2bc cos a. I can now substitute in what I know. So a is what I'm trying to find, so that's going to be this blue line, which means this angle here becomes capital A. B and C don't matter, so B and C are either side. They're my two slices of bread in my angle sandwich. So therefore I then go b squared, so 23 squared, plus 18 squared, minus 2 times 23 times 18 times cos 84. And I type that into my calculator. So 23 squared plus 18 squared minus 2 times 23 times 18 times cos 84. And that gives me 766.45. But remember, that's a squared, so therefore a is the square root of that. So square root of 766.45, and I get an answer of 27.68. So square root 766.45. Okay, so what we're saying is this distance here is 27.68 kilometers. Okay. Now we need to start thinking about how can I actually find this green part. So because I found this angle and this side, these two now match up, and now I've created a situation where these two match up as well. So from here you can then put your information together and think about the opposites where we looked at up here. So in this section here we were looking at angles matching sides. That's the situation we're now in with this question, because this angle matches this side, this angle matches this side. We're trying to find the angle, so we go back to this this part up here where we're doing sin A over A, and so you can see all of the bits are combining. So sin A, which is the section I'm trying to find, so that's that part, over A is equal to sin B, which is going to be this purple bit now, so I've changed that letter to B, over B, which is that one there. So you can see where the letters don't really matter. You need to manipulate them to suit the needs of what you're looking for. So sin of x, I'm going to call that sin of minus 1 because that's what I'll be using in a second, over A, which is 18, is equal to sin B, which is sin of 84, over B, which is 27.68. And then again, we've got to rearrange this. So this 18 goes over here, and I times that by 18. So my actual sum that I will be doing is sin minus 1, you'll open brackets, then you're doing sin 84 times 18 divided by 27.68. And when I work that out, so sin minus 1, I'm going to have to put the top part in brackets again. If you've got a calculator with a fraction button already on it, you can use the fraction button. So times 18, so that's the top of my fraction, all divided by 27.68. And then when I do that, I get an answer of 40.295. So what we're saying is this angle here actually now becomes 40.295 degrees. And then finally, because the question's actually asking you to find the bearing of town C from town A, it means that what you actually need to do is add that red part to that green part. So you're doing 40.295 plus your 47 that we've already got in that top corner. So plus 47, and you get an answer of 87.3 degrees there. Okay, so if you look at rounding that to one decimal place, but because we want to make this a bearing, bearings need to have 3 digits, so we put a 0 in front of it, and it'd be 087.3 degrees, or if it said to the nearest degree, it'd just be 0.87. Okay, so that's a really nice example of where your cosine rule, of where your sine rule can be linked together, and then your angles in parallel lines all comes together. Okay, lots of information in that video. It's probably worth going back and revisiting certain parts of it. Hope you found it useful. Hope it helps you, and I'll see you all in the next video.